my name is Ada and this is the second video of week 2. Today I will talk about techniques for discrete space location problems. We will explore methods for optimal facility location in discrete space environments. There is two scenarios in single facility location problem. The first one is that there is only one facility that serves all the customers. And the second one is that there is already an existing network of facilities and we make an addition to the flow. And also there is three analysis approaches which are qualitative, quantitative and hybrid analysis. I will talk about two different solution spaces. One kind of it is continuous space. Here there is an area that has possible locations and we can choose any points in this area. So we have infinite number of sets. Usually the mathematical model gives us the optimal solution here. However, it may be optimal but not feasible all the time, so in some cases we may not be able to choose that point. While in discrete space, there is the same area that has a finite feasible set of sides, and we try to choose the best one among them. I will today talk about qualitative analysis. And there is 5 steps for factor rating methods. The first one is identifying all the factors that has an impact on our location problem. After that, we assign weights to each factor by their importance and by how important we think they are. After that, we give weights between 0 to 1. We assign scores to each location for each factor, which are between 0 to 100. In the first step, we calculate weighted scores by multiplying weight by score for each factor. And we want this score to be high, which will give us the best location option. So finally, we select the location that has the highest weighted score. Here is an example. A company will open a new coffee shop, and there is 3 possible locations for that, discrete locations. A, B and C, and they want to choose the best one, but there's 3 factors that affect this decision. There's rent cost, customer traffic and competition. And here you see that we assigned weights for these factors 0.4, 0.4 and 0.2. After that, we give scores to each possible location for each factor. You can see the scores here. And then we make our calculations by multiplying scores and weights. You can see that A and B has the same score, which is 70, and C is higher than them with 74. So as a result, C is our best location option for this problem. But as I mentioned, that we assign weights to factors by ourselves. There is no rule for that, so it may change the result. Let's do a sensitivity analysis for this. Here you can see that we changed some of the weights of some factors Competition has the same factor, but rent and traffic factors are changed to 0.3 and 0.5. When we make our calculations, just like the other one, we see these results. You can see that C is even higher, and it's still the highest location with highest weight score. So we can easily say that location C is the best option after doing sensitivity analysis. Quantitative analysis has multiple techniques and several methods available for discrete space single facility problems that we can use. And there are specific applications for that. Each technique appropriate for specific objectives and constraints. In some cases, like for a facility such as fire station or hospital, that is important to maybe important to reach out quickly, we use a minimax model that minimizes the maximum distance to customers. Here you can see that general transportation models, parameters, and decision variables. For example, parameters can be unit transport cost from a warehouse to customer, or a supply capacity at warehouse may be another parameter, and demand at customer, while decision variables can be units transported from warehouse to customer, or total distribution cost. This kind of linear programming formulation optimizes the distribution from sources like a warehouse to destinations like customers. Thank you for watching. This is all for today's video.